want to look at this particular question on the board, we are still on the distance bearing problem. If you have not subscribed to the channel, kindly do so for me. So let's read the question together. An aeroplane leaves an airport A and flies on a bearing of 0.35 degrees for 1.5 hours at 600 kilometers per hour to an airport B. It then flies on a bearing of 130 degrees for 1.5 hours at 4 kilometers per hour to airport C. Now our task is to calculate the distance of C to A, and then we find the bearing of C from A. That is our question. Let's go through it to see how best we can approach this particular question. So the first thing that we are going to do is to draw our cardinal point as usual. So we have, so this is our north, our south, this is our east, and then this is our west. Now we know that in bearing, angles are measured from the north in a clockwise direction. And you agree with me that 35 degrees will fall within this quadrant. So we are going to measure from the north in this direction, and then we draw our distance. So we are saying that an airplane leaves an airport A. So this is an airport A on a bearing of 0.35 degrees for 1.5 hours at 600 kilometers per hour to airport B. So this is airport B, airport B. It then flies on a bearing of 130 degrees. So from airport B, it rested for some few seconds, and then it changed its course on a bearing of 130 degrees. So we are going to draw our cardinal point on airport B, and then we know that this is our north, this is our south, this is our east, and then this is our west. We know that 130 degrees will fall in the second quadrant if we are measuring from the north in the clockwise direction. So we are going to measure from the north in this particular direction, and then we draw our distance to airport C. Within the question, we don't know the distance that the plane flew from airport A to airport B. What we know is the hours that he flew. So he flew for 1.5 hours, and then the speed that he flew with. So the speed is what? 600 kilometers per hour. We don't know the distance. We know that speed is given as what? Distance all over what? Time. So from here, when we do some simple change of subject, we are going to get our distance to be what? Speed times what? Time. So we have our distance. Our speed is what? 600 kilometers per hour, and then our time is what? 1.5 hours. Now when you simplify, you are going to get 900 kilometers. So it means that the distance that the airplane flew from port A to port B is what? 900 kilometers. Now we also don't know the distance that the plane flew from port B to port C. But what we know is what? The hours that he flew, and then the speed that he flew with. So the hour is what? 1.5 hours, and then the speed that he flew with is what? 400 kilometers per hour. We don't know the distance, so we can calculate the distance, and we know that speed is given as distance all over time. We can say that our distance is equal to speed times what? Time. Our speed is 400 kilometers per hour times the time, 1.5 hours. So our distance is going to be what? 600 kilometers. Good. So it means that the distance from port B to port C is going to be 600 kilometers. And you agree with me that 600 kilometers is smaller than what? 900 kilometers, and therefore the length of B to C must be shorter than the length of A to B. So we can end somewhere here, and then we have 600 kilometers. So this is point C. Once we are done, we can join port A to port C. Good. So we are done with the diagram. Let's go through the question again to see if it is actually in line with the diagram on the board. An airplane leaves an airport A, so this is an airport A, and flies on a bearing of 35 degrees for 1.5 hours at 600 kilometers per hour to airport B. So that's going to give us 900 kilometers. It then flies from B on a bearing of 130 degrees. So on a bearing of 130 degrees for 1.5 hours at 400 kilometers per hour, and that's going to give us a distance of what? 600 kilometers to port C. We want to calculate the distance of C to A, so we have the distance from C towards A. So let's call this distance X, and then we want to find the bearing of C from A. Now, once we are done with the diagram, the next thing that you are going to do is to identify your transit point and then your transit angle. That is what I usually call it. The transit point is it at B, because at that very point, the plane relaxed for a few seconds and then it changed its direction of movement. So I call it the transit point, and this angle becomes what? The transit angle. So anytime we are done with the diagram, you look for your transit angle and then your transit point. So to find the transit angle, we are going to apply the alternate angle concept under the angle properties of parallel lines. So with this angle is alternate to this particular angle, and alternate angles are equal. So you can see that this angle is what? 35 degrees. That is alternate angle concept when you have two parallel lines being intersected by a transversal line. The angle from here is equal to the angle from here. So this is the concept that is helping us to find this particular angle. Now let's look for the other angle. Now we know that the measure of the angle from the north to the south pole is what? 180 degrees. But we have been given the measure of the angle from the north to this terminal line. So from the north to this terminal line to be what? 130 degrees. So to find this small angle, we are just going to subtract 130 from 180 to give us what? 50 degrees. So it means that this small angle is what? 50 degrees. Now let's add these two angles together. So we have 35 degrees plus 50 degrees. That gives us what? 85 degrees. Now if the transit angle is 90 degrees, then we are going to make use of what? The Pythagoras theorem and then the trig ratios. But if it is not 90 degrees, then we are going to make use of what? The sine and cosine rule. So we have the sine and then cosine rule. This is what we are going to use, since the angle at the transit point is not equal to 90 degrees. Now with the sine and cosine rule, when you have any triangle which is not a right angle triangle, and then you have the length here to be, let's say, A, and then you have B, and then C, and then we have an angle that is positioned at this 0 point. The cosine rule is giving us A squared, since we are looking for the length of A, we are going to get A squared is equal to B squared plus C squared minus 2B times C cos of the angle theta. So we are going to apply this cosine rule to find the length of A to C. So from this diagram, we can say that our x squared is equal to 900 squared plus 600 squared minus 2 900 times 600 cos of the angle cos of the angle 85 degrees. So let's point them on the calculator. So we are going to have 900 squared plus 600 squared, that is giving us 11117 and then 4 zeros, and then we have minus. So let's point this 2 on the calculator. So we have 2 times 900 times 600 times cos of the angle 85, that is giving us 94128.2. So we have our s squared is equal to, so minus 1171234. So we have 10,75871.798. Now let's take the square root on both sides of the equation to find the value for x. So we have our x is equal to, we have 1037.24 kilometers. So that is the distance from A to C. Now we are done with the first one, which is I. Now let's move on to II. We want to find the bearing of C from A. The bearing of C from A, it means the bearing is going to take place at port A. And in doing that, we are going to start measuring from the north till we get to this line. So we are going to measure up to this particular line. We already know this particular angle, so we need to find this angle so that we sum these two angles to give us the bearing of C from A. So let's call this angle angle theta. Nowadays, we are going to make use of what? The sine rule. The sine rule. So the sine rule, we are going to use the distance x all over sine of the angle, which is this 85, is equal to the distance 600 all over sine of the angle theta. We know that our x is 1037.24. So we can say that sine theta is equal to 600 sine of the angle 85 divided by x. Our x is this, so we have 1037.24. So let's point it on your calculator. So we have 600 times sine 85. So we have our sine theta is equal to 0.57625. We are looking for the angle theta, so we have theta is equal to the sine inverse of 0.57625. So you can see that our angle theta is equal to, we have 6 sine inverse of answer, that is giving us 35.187 degrees. We can round it to the nearest degree, which is theta is equal to 35 degrees. Now we know angle theta, which is what? 35 degrees. So the bearing of C from A is going to be what? 35, which is this angle plus this angle. That is giving us what? 70 degrees. This brings us to the end of today's lesson. See you tomorrow. Bye bye. But please don't forget to subscribe to my channel for more episodes. See you.